Hi everyone. This is our final product presentation for Project Innovate Future. So this is our team. We have our stakeholders, Dex, Lightsman, and Notel as our tutor, and we have team leads and DevOps and developers. So this project, Innovate Future Foundation, serves as an engaging platform to introduce IFS mission, showcase its work, and provide a centralized hub for managing upcoming events. This project enables organizations and end users plan, manage, and preview the international learning activities in one place.
So through our project, we adopt modern methodologies in project management, system architecture, and technique stacks. At the start, our requirements were unclear, so we took an iterative approach to gradually refine them, avoiding duplicate work. We followed Agile Scrum using Jira, GitHub, and Discord for efficient tracking and collaboration. Can you click Jira board?
Yeah. Okay.
Yeah. In Jira, we planned our work across 6 sprints, breaking tasks into epics, tickets, and subtasks as needed. Okay, can we go back and click GitHub repos? And in GitHub, we manage our code in front-end and back-end repos with each ticket linked to a branch and reviews through pull requests. And these are, commits of the project. For communication, we use Discord for daily stand-up, sprint planning, and retrospectives. Our project was structured and also flexible, balancing efficiency with adaptability. We have already done our best to standardize the project development process. Next slide, please. For our system architecture, the front-end and back-end communicate through RESTful APIs to ensure smooth and secure data flow. Next slide, please. Okay. On the front-end, handles user interactions, while the back-end process requests, manages business logic, and stores data in PostgreSQL. We also created a bucket on cloud to store our static assets, include build files and images. Next slide, please. Since we are building a multi-tenant SaaS platform, role-based access was a major challenge. We have 6 roles, each with different responsibilities. Next, please. We start with the database, where the core resources resolve around organizations, user resources, and tool resources. Data isolation is enforced using org ID, which serves as tenant's identity. Next, please. Next slide. On the front end, UI elements like menu are rendered dynamically based on role permissions defined in the backend permission config file. These permissions are fetched via an API to determine the appropriate UI for each role. However, front-end control alone is not secure, so the backend validates JWT tokens, extracts org ID, and ensures users can only access authorized resources. Next, please. Yeah, next is our tech stacks. Next. Okay, our main tech stack includes React, TypeScript, Vite, 10-stack table, query, and Taiwan 6 is for frontend. And the ASP.NET Core Entity Framework, Mediate are PostgreSQL for backend. Of course, there are some popular packages are used in the project as needed. Next, please. Xiaobao will introduce the authentication part of the project.
Thank you. In our project, we have 2 ways to register. One is organization or the main registration. First thing is to fill in the organization details, then fill in personal details, then submit the form to fetch register organization admin API. When the user when receive a verification email, user need to confirm. If verified successful, then we'll direct it to the dashboard page. Otherwise, we'll show the invalid message. Next page, please. Next is user invitation. Organization admin invites user via email. System sends an invited email with an verification link. Next page, please. Then, when the email sent successful, when the invited email sent successful, then let invited user to check their email and click verification link to get temporary password for login. Next page, please. For authentication, we have 3 APIs: login and get me and logout. We use JSON Web Token to generate an access token. The access token is stored in cookies for security. The reason we use JSON Web Token because it is status authentication. No need to store session data on the survey. For security view, token is signed and verified. Next page, please. For authorization part, inside the access token, we only store profile ID in the claims, easy and safety, because profile ID in our database can allow us to fetch all the informations that we want to retrieve. Thank you.
So for uploading and processing images is a very common requirement in web applications. Our approach involves 2 key steps here: image cropping and uploading to AWS S3. Before uploading, users can crop their image to a desired size. This ensures that only the necessary part of the image is stored, optimizing the storage and user experience. So once the image is ready, it is uploaded to AWS S3, a secure and scalable cloud storage solution. After the upload, we receive an S3 URL, which can be used to display or process the image further. Regarding the forms, we utilize the React hook form to handle the form inputs and validations. This is a demo which includes all the features mentioned above.
Okay, so one of our key optimizations is server-side pagination. Instead of loading on large datasets at once, the front-end features only what needed using text-and query, while the backend returns paginated data with metadata for smoother navigation. Next slide, please. As shown, each query can include specific parameters to retrieve the corresponding data. Next slide, please. To further optimize, we use low-dash debounce to limit unnecessary API calls in search fields. Not every change of search content trigger an API call. Next slide, please. Raymond will talk more about responsive design UI.
Okay, thank you, Chen. I'm Raymond, and today I'd like to introduce the responsive design principle used in our landing page as an example and explain how they improve the user experience across the different devices. Next page, please. First of all, we do have a consideration in mobile users and create different layout for different screen sizes. For example, in larger screens, elements are spaced in the better content balance, but also in the smaller screens, the layout will more compact and stacked for readability. So users on all devices can optimize the experience without unnecessary clutter. Next page, please. To make the layout adaptable, we avoid the fixed pixel values and instead using relative units like the percentage, REM, or EM to have the page remain visually consistent without overflowing or shrinking too much. So you can see that content will automatically fit in different kinds of the content. Next page, please. We also use breaking points to define different layouts for different screen sizes. For example, the layout is single column in mobile, but switches in multi-column in large screens. So the page will dynamically adapt and maximize usability across the screen sizes. And next page, please. Also, we leverage the flexible and the grid to create adaptive structure layout, which we use these techniques a more structured, organized layout and adjust it intelligently to different devices. So in conclusion, with the responsive design, our landing page is not only visually appealing, but also functionality and user-friendly across all devices. This ensures a consistent and engaging experience for all the users. Next page, please. And in our project, we also follow modern front-end best practice by using component-based design, a unified UID system, and a smooth animation. Next page, please. We adapted a highly componentized architecture, making it easier to maintain and scale. So we were using the registration process as an example. Instead of writing a separate form for elements and logic for different pages, we encapsulated them into a reusable component, which they have advantages like can you reduce the code duplication, ensure consistency across the application, and make the updates much easier. Next page, please. To maintain a consistent design language, we also use the chassis UI. For example, the bottoms, the inputs, and the models all share with the styling, behavior, and accessibility features. And also we use the smooth page transition with the framer motion. These animations makes interaction feel more natural and engaging, improving the overall usability for the application. The next page, please. Why this matters? By combining the component-based UI, a unified UI system, and the framework motion animations, we achieve these benefits like increased development efficiency, easier maintenance, and a better user experience. So in summary, our use of the reusable components, chassis and UI and framework motion help us to create visually appealing, efficient, and user-friendly interface. By following this system approach, we streamline the development, delivering a consistent and a smooth experience for the users. And that's the end of my part. Thank you.
This is the demo about the responsive UI and other features we've delivered so far. And we created an account for demo use with some seed data injected. Here is our dashboard. Tools, users, different roles with grid table. And this is nested table. We can select different filters, pages, to get different data. I want to show not every click triggers an API call because timestamp query caches data for a set duration. This significantly reduced unnecessary API requests by serving cache data when available, improving performance and efficiency. And about tool part and dashboard part, we only build static UI without API linked because of the time constraint. Yeah, this is drop and drag component package. Yeah, I think that's it. Further development will continue later. Yeah, we are sure the developed part can be ready to use. Okay, thank you.
Okay. Hello, guys. Can you hear me?
Yes.
Okay, so good evening, ladies and gentlemen. It's my pleasure to introduce our project on backend infrastructure and DevOps considerations to our STME peers and industry thought leaders. And first of all, as you can see, this is our infrastructure overview. All our domains are managed by the AWS Global High Available DNS service, which is Route 53. And then after we're hitting the edge service CloudFront, we integrate both our front end and back end with into our CloudFront as different origins. And the front end part, we have mainly two buckets. One bucket is for the static contents, and the other one is for the images, and also including those images that user uploaded. And for the backend part, we use the API gateway to expose our backend service and integrate with Cloud Map to automatically discover our Fargate service. This will ensure high availability and also auto load balancing. And for the monitoring and logging part, we use CloudWatch to ingest all of the logs and then sync them to the third-party service that we built in the other code. For instance, we built our Elasticsearch and Kibana in Google Cloud GCE. And next page, please. And for the environment design part, we use AWS organizations to provide better environment segregation. And in our case, we have two AWS organizations. One is dev organization, which is solely used to manage dev account. And the other one is main organization, which is used to manage our UAT account, staging account, and production account. Next page, please. As you can see, we have mainly 5 branches. To break them down, we have 3 long life branch, dev, UAT, main. You might be curious that why we put the branching strategy in the environment design, because each of those long life branches are actually logically representing an environment. They are development environments, UAT environments, and production environments, respectively. Codes are promoting from dev to UAT branch and finally into the main branch. For the short life branches, developers mainly develop against the dev branch. They check out the feature branch from dev branch. And also we have a bug fix branch, which can be used to patch hot fix to the UAT branch directly. This clear branching design is very helpful for our pipeline design, which will be covered in our later section. Next page, please. The access control is a crucial part in a project in an organization. Users' permissions must be restricted and managed. Besides, the services and the pipelines that act as human also need to be taken into consideration. For the SSO user management, we use AWS IAM Identity Center to manage our user access across different environments, including dev, UAT, and production. Users are managed in SSO groups so that we can ease the administration overhead. We have developer group, we have DevOps group, we have DevOps lead group, and at the end, we have a platform admin, which have full access, full control across all the environments. Next page, please. For the pipeline role management, our project used GitHub Action to automate our pipeline jobs. And with the help of OIDC, we do not need to expose and store our secrets in third-party service. And as you can see, all the workflow using OIDC to get temporary credentials based on the different assumed policies. Basically, those policies, including 3 different factors: which repository is it come from, which branch is it come from, and which environment is it going to deploy to. And all of them are managed by Terraform. Next page, please. So Terraform is absolutely the most fun part of our project. We adopt enterprise IAC code management. You remember the user access control part that we mentioned before? With the help of Terraform, SSO users can be managed with just a simple pull request. We also tried our best to write our Terraform module as generic as possible for future reusing and for easier maintenance. And we separate our infrastructure code into multiple repositories to provide better segregation and provision speed. And as you can see in the image, there is a Bootstrap. There's a Bootstrap repository called Terraform Bootstrap. That one is used to manage all the Terraform backends, all the TF logs, the TF states, and also the temporary files for all the other Terraform repository. So you don't need to creating them manually and assign those secrets every time when you create a new Terraform repository. And next page, please. I will give this part to Dylan. Dylan, are you there?
I'm Dylan. Today I will be talking about our front-end CI/CD pipeline and preview environment. This setup is important for our workflow, helping us quickly develop new features while maintaining quality. I will explain the architecture, the workflow, and how the preview environment works, as well as the benefits we have seen. Our setup uses a multi-environment approach with development, UAT, and production. We use GitHub Action for the workflow, AWS S3 for the static hosting, and CloudFront for the content delivery. Security is handled using OIDC authentication with role-based access, so we don't need long-lived credentials. This makes the system scalable and secure. Our CI/CD pipeline has 2 main parts: build and test and deployment. The build and test pipeline is triggered by pull requests or changes to main branches. It installs in dependencies, run test, creates a production build, and prepare file for deployment. The deployment pipeline handles the specific settings for each environment, deploys to S3, and invalidates CloudFront caches. This workflow is reusable, so it can be used across different environments with some customization. A major feature is the preview environment for each pull request. It automatically creates a unique environment with its own URL. Each PR gets its own S3 bucket named by the PR number and title. It also triggers the backend to create a matching API preview, ensuring full stack testing. Once the PR is merged or closed, the resources are cleaned up, so we don't have unused environment. All of this happens automatically with no need for manual intervention. This system benefits us in 3 main areas. First, it improves developers' experience by providing quick feedback in an isolated environment. Second, it helps quality assurance by allowing validation before merging. Finally, it boosts operational efficiency by automating resource management and reducing manual errors. To sum up, our front-end CI/CD and preview environment solution has improved our development process by automating development and offering isolated testing environments. We are able to release features faster and with higher quality. Okay, that's all from my part. Thank you. Now let me head over to YC.
Okay, next page, please. So for the CI/CD design part, our pipeline and workflow work closely against our branching strategy. So as you can see, when developer from left to right, for the first column, when developer push a started pull request from feature branch to dev branch, it will trigger a dev preview CI workflow, and it will push and tag image. And after that image is push and tag and also tested, it will be deployed to a preview environment. And after that, when it is merged, it will then trigger a new workflow, which is dev CI and dev CD, which is similar to dev preview CI and dev preview CD, but it's work against the dev branch. And after the developer, after we have developed enough features, we want to deploy them to UAT branch, then we just create a pull request from dev to UAT, and so on. What needs to be mentioned is that we have a bug fix. We have a bug fix branch, which is a little bit different. That one is triggered from only the bug fix branch to the UAT branch. And for the production part, the production CI, they actually do not need the permission to push image because we do not allow that, and only tested features on the UAT service, our UAT branch can be promoted to the production branch. And after that, when we push, when the pull request merge on the main branch, it will trigger the deployment pipeline on the production environment. By adopting these image promoting best practice, we can achieve fast reflect and fast deploy because no rebuild is required, and least privilege, and also space saving because we're using a central ECR repo. And next page, please. Now let me hand over to Fan.
We monitor ECS cluster using Amazon CloudWatch. At top of this slide, you can see the CloudWatch dashboard. It provides real-time metrics and alarm status for CPU and memory usage. The alarm will trigger when usage is above 80% for 3 out of 5 data points over a 25-minute window. When either alarm is triggered, an email is sent via Amazon SNS to ensure our team is immediately informed. Now Henry will go over logging on next slide.
Okay, next slide, please. Okay, last but not least, we have our login system. Here we deploy our Elasticsearch cluster on Google Cloud Platform with the Elasticsearch nodes and Kibana node to efficiently store, search, and visual log data. Our cluster consists of 2 Elasticsearch nodes, each serving a crucial role. Node 1, which is master node. This node is responsible for coordinating the cluster, managing metadata, and store a portion of log data. And node 2, which is a replica data node. This node stores replica shards to ensure redundancy and also helps with search queries to distribute the load. Sitting alongside our Elasticsearch cluster, we have one Kibana node. Kibana provides the user-friendly interface that allows us to search and analyze log data efficiently, build interactive dashboard for real-time insights, set up alerts to detect anomalies or security threats. Kibana transforms our raw logs into visual representations, making it easier to understand network activity, detect trends, and troubleshoot issues. One example of how we use this system is with VPC flow logs. These logs capture details about the traffic flowing in and out of our cloud network, including source, destination, ports, and protocols. Instead of manually shifting through these raw logs, we send them to our Elasticsearch cluster, where they are indexed and stored. Then with Kibana, we can create dashboards that visualize network activity, helping us identify suspicious traffic, troubleshoot connectivity issues, and ensure compliancy. Okay, next slide, please. So that's all for our presentation. Thank you for listening. We are Innovate Future Association.
Thank you. This is the end of our presentation. Yeah.
谢谢 Innovate Future 同学们大家的展示。那接下来就是点评和就是沟通的环节，咱们老师、嘉宾还有同学们看看有没有什么问题要问。
你们 PPT 是谁做的啊？设计？
PPT 都是就是各自做各自的呀。
对，因为我是发现你们 PPT 做的还是很专业的，并没有用设计师去改，所以我感觉还是很专业的整个设计。
OK，我觉得他们 developer 那部分写的贼好，写的好多，我们后面都是凑数的感觉。
对，还有这个项目本身呢，就是无论从这个 full stack 也好，DevOps 也好，已经达到了一个真正的 production 环境下的一个标准吧。不论是从这个组是用的 Jira，从头到尾，包括 developer 的那个 branching 也好，这个 PR review，还有这个 access control。这个 UAT 测试和 production 的环境的全部是分开的，这几乎算是一个 production ready 的一个项目了。而且我就是非常 impress，在短短2、3个月做成这样，还是做的非常非常棒的，对这个一个商业的项目打下了一个非常好的基础。我觉得这个 DevOps 和 Dev 组表现的非常好。
谢谢老师。
对，我一开始，你们还记得我一开始还觉得对这个组有点担心，上次去看的时候并不是这个样子，然后现在看完全是另一种项目，我觉得整体做的还是非常专业的。
因为在项目的初期，我们经过了几次方向的调整，但是在经过小组各个团队之间的这个协作，最后把方向定下来以后，我们的效率其实蛮高的，对，然后争取在这个 deadline 之前，尽可能多的完成一些 features 吧，对。
我有个问题，我感觉这个 UI 还是挺好看的，是你们有设计师吗？
UI，是这样的，我们有设计师，然后我们也有借鉴了这个市面上的竞品，然后我们会去 reference，然后会去改善，然后因为结合了当前就是比较热门的那些商业的样品，我们都会结合去看，但我们也是有设计师的，对。
这个 UI 用的是叫 Sharpsen 是吧？
是的。
我们那个 landing page 是有专门的设计师做的，然后那个平台部分的都是开发同学设计的，主要是前同学设计。
我是上次看你们组，然后我觉得万一出大事儿，然后我就赶紧，我为了你们这项目雇了4个设计师，去换了4个，最终是确定这一个。你们看到的是第4个版本的设计。
哦，这样。那这个 SaaS 它用起来就是说，够丰富吗？你们是不是有时候还有需要自己写一些，或者是再用别的库怎样？
需要的，需要的。嗯，
山森它不是那种提供丰富 UI 的一个 UI 库，它是 customize 最大化的一个 UI 库，它是可供我们就是最大化的 customize，根据我们自己设计的 UI 是
哦，
这样子。
是的，是的，对，是我记得我看到官网的时候，它不是特别丰富，就是说你们还要用 Tailwind 自己写是吗？
没错。
对，我们需要调整。
哦，好的。我还有最后一个问题，就是我看你们有那个有文字的一些 content management，那个在前端是用了一个包吗？还是怎样？有点像写个 blog 一样的东西。
文字
对，就是处理文字的一个文本框，就是一个在里面可以，
您是说 rich
，rich text 吗？
text 是吗？
对对对对，
啊，
对，那是用了一个库叫
好
TikTok。
，TikTok。好的，谢谢谢谢，挺漂亮的。
还有一点是，这个网站就是我们之间就是举办的活动的，就是 Dev 组的话，很及时的把我们之前做的一次活动直接加上去了。也就是说，他们在做网站的过程当中的话，其实我们是在一直 unrolling 的在做不同的活动的，也就是相当于 Dev 组属于一个真正的在做一个 production 环境下的一个工作。我们有像这些有些照片都是我们做活动及时传给他们，然后他们就更新到页面上。大家可以看到有四个不同的 events，这些都是真实的 events。最近的一个在1月底嘛，然后刚好那个时候应该是在这个项目的中期左右，然后就 Dev 组和 DevOps 非常给力，那时候刚好是而且是春节期间，就很及时的把这个及时的做了调整。这个表现，我觉得在一个3个月的时间做成一个这样的效果，真的是非常的惊喜吧。
谢谢老师。
而且这个设计其实给你们很短时间啊，给的也就2、3个星期吧，然后你们快速把它设计全部换了一遍，还挺快。
这也多亏了我们当时在前期设计项目的时候，足够的把它 modularization，所以我们也是花了大量的人力和时间，然后去尽可能的完成设计方面的要求。
对，我觉得还是很好的，因为我担心的是，我好不容易找设计师设计，我怕你们不做，所以你
不会的。
看我一直在催，结果没想到全做完了，还是很不错的做的。然后我想问的是，你们的 IAM 是怎么设计的？就是 Davos 那边，因为没有特别细的讲。
IAM 怎么说呢？您是想问我们的这个 service 的 access control，还是说我们 user 的 access control？
user 的，就是你们是通过几层做的 IAM？
你可以下一页先在这页放着吧。就是首先我们这个用的是那个organization 去管理的嘛，然后理想状况下肯定是一个 organization 去管理这些东西，但是因为我们这个为了更好的separation，然后还有 billing 什么的，所以我们就分成了2个 organization，但实际上这个东西给我们增加了很多开发上的困难。然后基本上就是再通过这个 management account，你下一页，再下一页。对对，通过那个 production 那个我们的 production account 实际上也是这个 organization 的 management account，然后我们在通过管理这个 account 上面的 IAM identity center，用它去管理这个用户在 production 环境还有 UAT 环境的这个权限。然后我这里这个图其实画的简略了一点，因为我们实际上是2个 organization，那个底下那个 dev account 实际上是上面还连着一个 dev organization。然后这个 dev organization 和 main organization 是分成了2个 Terraform 的 folder 去管理的，所以说也都是基本上就是一件部署的，然后就是 然后接下来下面就是会有一些 group，然后给这些 user 给他 assign 这个 group，然后我们再通过给这个 group 去添加这个 permission sets，然后以此来实现的这种管理。
这里面还
那你们
有一部分是这个新的用户，比如说新的 developer 的 onboarding，你们也考虑到了，对吗？就是怎么去 onboarding 新的 user 进去，也是通过 IC 来管理的。
对对，你下2页翻一下，对，你看下面这个啊不，在下张图，对，就是那个黑色的那个截图，这个就是我们那个 access control 那个里面截的一张图，然后我们这个 project 是 public repository，大家都可以看，就是你这个东西我们怎么说呢？我们把整个 Terraform 的这个 CI/CD 设计的，我都觉得都有点过度设计了。就是你提 pull request 的时候，首先我们的这个呃 Terraform 的环境的管理并不是用的 branching base，用的是 folder base。因为如果用 branching base 的话，首先第一，你的这个3个 environment，你的这个 infrastructure 必须 identical。其次呢，这个东西你必须，如果你想给它最终部署的话，你必须 walk through entire branching promotion，这样的话就太复杂，所以我们这个是基于 folder based 的一个 multi environment management。然后当一个用户编辑了，比如说我在这个，我想添加自己，我给自己 onboarding，然后基本就是加一行自己的信息，自己的邮箱是什么呀，然后这个姓名是什么，然后添加完进去之后，就再指定一下自己是哪个组的，然后这个 pull request 提出来之后，我们就会触发一个 CI pipeline，这个 CI pipeline 就会看你到底是哪个 folder 改的，我是需要给它 provision 到哪个 organization 里面，然后去执行一个 Terraform plan，然后把这个 plan 用那个 bot 打印输出到那个 pull request 里面。然后这就是你们看到的那个 bot 发出的这个 Terraform plan，这都是可以展开的。然后我们比如说管理人吧，你比如说我看的话，就是看一下这个东西他写的对不对，然后他给自己 assign 的 group 对不对，然后他的信息填的对不对，然后就给他 approve 就可以，approve 完了之后 merge 之后，这个 Terraform plan 就会被 apply 掉，而且这个 Terraform plan 还是就是因为我们是指定输出的这个 plan，所以说可以保证一定是我们输出的 plan，而不是后面它重新 apply 的一个新的 plan。
对，这样的一个完全可以满足一个20-30人的 developer 一个小团队的一个 access control 的需求了。
那这个 permission，因为一个账号最多10个 permission，你们是用 group 去做的管理吗？还是没有用到这么多的 permission？一个 IM 账号的话，
我们用的是呃您说的这个 permission 这个部分应该是属于是 permission set 那个部分的设置。我们这 onboard 的话，其实就是指用户的添加和 attachment 和那个 permission set attachment。如果要想弄特别细粒度、特别复杂的那种呃 permission 的话，那确实还需要稍微再多写点东西，因为我们的这个 group 的这个 assign 的 permission set 其实比较简单，目前来说。还是需要有更多的 permission set 的设计。完了之后，但是我们这个整体结构是完全支持你这样做。
嗯，OK，我还想问一个超出这个P3这个级别的问题，就是反正匠人这边出现过一个问题是，任何的 DevOps 都可以编写 Terraform，然后呢也有 branch，但是呢 CI/CD 也是开放权限的，也就是说会有一个漏洞是，所有只要是 DevOps 的话，它在不需要 merge 这一个 branch 的前提下，可以在 CI/CD 上跑它的 branch 或者它的内容，那也就是说，它可以用 Terraform 去绕过pull request，然后自动去在后端直接启用 service。那像这种情况的话，有办法解决吗？
其实你说的这个问题，我们当时在做的时候还真没有考虑这么多，所以其实我们很多 pipeline 是 可以你手动去触发的，但是实际上，可以 GitHub 的话，它可以支持你给 deployment 做这个protection。你这个 deployment，比如说你可以development 的环境，比如说你无所谓，那就无所谓了。但是 UAT 环境和 production 环境，你可以设置它跑这个 pipeline 之前需要通过谁的认可和认证才可以去跑。那么这样的话，其实就是可以达到一定程度的这种限制吧。另外还有一点就是我们所有的 pipeline，所有的环境，就是每一个环境精确到某一个环境某一个这个 repository，它的这个 pipeline 它的 role 都是分开去设计的，也就是说它只包含 least privilege to provision its required resources。所以说这部分我们也做了这个限制。
我是觉得可以做一个 cross account 去把环境完全隔离，然后 production 环境的话，我觉得可以只用单独的几个账号有权限可以去部署 Terraform，这样应该就可以了。
好。